The EA-18G Growler went first, before the B-2 crossed into Iranian airspace, before the first bomb was released. Before any strike aircraft entered Iranian radar coverage, the Growler was already there, finding every radar in the network, mapping every frequency, jamming the specific wavelengths Iran's integrated air defense depends on, and putting a missile on every antenna that stayed on long enough to transmit. By the time the B-2 arrived, Iran's air defense was blind, disconnected, and unable to generate a single weapons quality track. Not destroyed, silenced. Everyone covered the B-2. Its 0.0001 square meter radar cross-section, the $2.1 billion airframe. The fact that it launched from Missouri and Iranian radar registered nothing. That was the headline. The Growler is the reason the headline was possible, and nobody in mainstream coverage explained it. The EA-18G Growler is a carrier-based electronic warfare aircraft. 2 crew, built on the FA-18 Super Hornet airframe. From the outside, it looks almost identical to a strike jet. Same platform, same twin engines, same general silhouette. Walk up to one on the flight deck, and the difference only becomes clear when you look at the wing stations. Instead of bombs and air-to-air missiles, it carries jamming pods and anti-radiation missiles, equipment specifically designed to locate, suppress, and physically destroy enemy radar systems before the strike package arrives. It is the most important aircraft in U.S. naval aviation that almost nobody talks about. The aircraft that makes every other aircraft's job possible. Here is what it does, precisely how it dismantled Iran's air defense network, and why no other air force on Earth, not Russia, not China, operates anything that comes close. The Growler attacks in 2 ways simultaneously, soft kill and hard kill. Understanding both is essential to understanding what happened to Iran's air defense. Soft kill is jamming. The AN/ALQ-99 tactical jamming system, carried in pods on the Growler's wingtips and center line, can detect enemy radar signals across a wide range of frequencies and flood those frequencies with electronic noise. Not ordinary noise. Noise thousands of times stronger than the faint echo a radar is trying to detect from a distant aircraft. Here is how radar works at a basic level. A radar station transmits a pulse of electromagnetic energy and listens for it to bounce back from a target. The return signal, the echo, is extremely weak. An aircraft 200 kilometers away reflects a tiny fraction of the original transmitted energy. The radar's receiver is exquisitely sensitive, specifically because it has to detect that tiny return against the natural background noise of the electromagnetic environment. The Growler exploits that sensitivity. By transmitting a jamming signal on the exact frequency the radar is operating on, at thousands of times the power of the echo the radar is trying to detect, it overwhelms the receiver completely. The echo is buried. The radar operator's display shows noise instead of a return. There is no way to distinguish clean sky with an invisible aircraft from sky blanketed in jamming. Both produce the same display, static. Before any jamming begins, the Growler's AN/ALQ-218 receiver has already mapped the entire threat environment. Every radar that transmits reveals itself. Its exact frequency, its pulse repetition interval, its scan rate, its geographic position. Electronic warfare operators call this building the electronic order of battle. Once that picture is complete, the Growler knows exactly which frequencies to target, in which sequence, at which power levels to be most effective against each specific system. Now consider what this means for Iran's Bavar 373 specifically. The Bavar 373 uses long wavelength radar frequencies. Iranian engineers chose this deliberately, because long wavelengths interact less effectively with radar-absorbing coatings than the higher frequencies those coatings were designed against. This was a genuine technical attempt to counter stealth aircraft. A real engineering insight turned into a real weapon system. But long wavelength transmitters are also easier to detect, easier to locate, and easier to jam. The same design decision that gave the Bavar 373 a theoretical advantage against the B-2 made it more exposed to the Growler's receiver and jamming systems. The Growler didn't just suppress Iran's radar, it suppressed the specific system Iran built to counter stealth, the counter to the counter. The hard kill option is the AGM-88 high-speed anti-radiation missile, HARM. The HARM seeker head locks onto the specific frequency signature of a radar transmitter. Once locked, if that radar transmits long enough to generate any kind of track on any target, the HARM launches and homes autonomously on the antenna. No ongoing guidance from the Growler after release. Range, approximately 150 kilometers at altitude. Terminal speed, Mach 2. The radar dish is the target. The missile follows the radar's own signal back to its source. The Iranian radar operator now faces a choice that has no survivable option. Transmit and expose the antenna to a harm that may already be in the air following the signal home. Stay silent and guarantee that no incoming aircraft will be detected, no track will be generated, no missile battery will receive targeting data. There is no combination of transmit and don't transmit that simultaneously protects the operator and produces the air picture the defense needs. Here is the part that almost no coverage addressed, because most coverage thinks about air defense as individual radar sites. It is not. Iran's air defense is an integrated air defense system, IADS. Individual radar sites detect targets and pass that data through a command and control structure to coordinate intercept aircraft and surface-to-air missile batteries into a coherent defensive response. The system's strength is specifically the integration. No single radar needs a perfect track on every target, as long as the network as a whole maintains a coherent air picture. Sites hand off contacts when a target leaves their coverage arc. Control centers fuse data from multiple sites into a single track. The missile battery receives a targeting solution built from multiple inputs, and the solution is better and more reliable than anything any single radar could generate alone. This is why sophisticated air defense networks are so much harder to defeat than individual radar sites. You can suppress one radar and another picks up the track. You can jam one frequency and the network routes around it. The whole is genuinely stronger than the sum of its parts. The Growler attacks the sum and the parts simultaneously. Individual radar sites communicate with control centers through radio data links. Dedicated frequencies carrying track data, threat assessments, target handoffs, and engagement orders. These data link frequencies are as vulnerable to the Growler's jamming as the surveillance radar frequencies. When the Growler jams both simultaneously, the result is not just that individual radars go blind, the network itself goes deaf. A radar site may register an anomaly on its own local display. The operator may see something that looks like a possible contact, but the transmission that would carry that contact report to the command center never arrives. The command center never fuses it into the picture. The missile battery never receives a targeting solution. The detection happened and produced nothing. Picture this from inside an Iranian air defense command center in the minutes before the strikes. Reports from individual radar sites are fragmenting. Some sites going silent, others transmitting noise. The integrated picture that should be flowing in from across the network is producing confusion instead of clarity. Controllers are trying to re-establish contact with sites that aren't responding. Every attempt to transmit an inquiry adds another emission source to the Growler's target list. Iran's air defense is only as strong as the data it can share between sites. The Growler made every site deaf and mute simultaneously, so the network stopped existing as a network. The B-2 arrived into this. Not physically destroyed, most of the physical radars were still standing, but unable to communicate, unable to coordinate, unable to generate the integrated picture that a weapons controller needs to commit a missile battery against a target it cannot continuously track. The B-2 doesn't need to be invisible to every individual radar. It needs to be untrackable by the system as a whole. The Growler guaranteed that. There is no other aircraft in service anywhere on Earth that does what the EA-18G Growler does. Dedicated airborne electronic attack in support of a strike package at carrier strike range, combining standoff jamming with hard kill capability. Operated by a crew trained specifically for this role. This has been true for decades. The Growler's predecessor, the EA-6B Prowler, provided this capability from the 1970s onward, in Vietnam, in the Gulf War, in Kosovo, in Iraq, and Afghanistan. Every U.S. air campaign that succeeded in penetrating defended airspace since 1970 did so with dedicated electronic attack support. When the U.S. military conducted operations without it, a handful of historical cases where coordination failed or assets weren't available, the difference in losses was measurable. Russia's Kibini electronic warfare pod, fitted to the Su-35 and Su-57, is a self-protection jammer. It protects the aircraft carrying it from radar-guided missiles aimed at that specific aircraft. It does not support other aircraft in the strike package. It cannot jam a target area's radar network from standoff range. It carries no harm equivalent. Russia has no dedicated airborne electronic attack platform that performs the Growler's role. China's J-16D is the most credible attempt to build a comparable capability. an electronic warfare variant of the J-16 strike aircraft, developed directly in response to the Growler's demonstrated effectiveness. It entered service in 2020. Even Chinese defense analysts describe it as still developing toward the operational maturity of a system refined through continuous combat use since the early 1990s. More than 30 years of operational lessons, the J-16D has no equivalent history to draw on. Whether the J-16D can actually perform the Growler's full role against a sophisticated IADS in a real operational environment is not yet confirmed by any combat use. The U.S. Marine Corps retired its EA-6B Prowlers without replacing them. All U.S. dedicated airborne electronic attack capability is now concentrated in Navy Growler squadrons, embarked on aircraft carriers. Every strike package that requires dedicated electronic attack support requires a Growler, which requires a carrier nearby. This is one additional dimension of what two carrier strike groups in the region actually represent, beyond the aircraft and missiles they carry. Iran has no equivalent. Russia has nothing close to this role. China is building toward one and has not yet demonstrated it works. The lesson from every U.S. air campaign since Desert Storm in 1991 is consistent, and it has never changed, despite every adversary's attempt to engineer around it. Electronic warfare is not a supplementary capability that gets layered onto a strike package. It is the prerequisite that makes the rest of the package possible. Before the first bomb can be delivered with acceptable risk to the crew, the adversary's ability to detect, track, and engage incoming aircraft must be suppressed or destroyed. That is not a principle discovered recently. It is a conclusion drawn from 40 years of operations against defended airspace. The Growler is the current implementation. The B-2's stealth is then the final layer, handling what the Growler cannot fully suppress in the time available. Together, they form a layered penetration system that no adversary has yet demonstrated the operational ability to defeat. Iran spent billions constructing air defenses. The Bavar 373, the S-300 Mu-2 batteries purchased from Russia. The Tor-M 1 short-range systems protecting critical installations. The legacy Hawk batteries that have been in operational service since before the Islamic Republic existed. All of it planned, funded, positioned, and maintained specifically to defend against exactly the kind of strike that was conducted against it. The Growler did not destroy all of it. It made all of it irrelevant for the duration of each strike. The radars still existed. The missile batteries were still armed. The operators were still at their stations. But the network that integrates those components into a coherent defense was severed, site by site, frequency by frequency, data link by data link, before the B-2 entered coverage. For China, the lesson is operationally specific. Building a more powerful radar does not help if the Growler can locate the antenna the moment it transmits and has a harm ready for exactly that transmission. Building a denser integrated air defense network does not help if the Growler can jam the data links that make the network function as more than a collection of isolated, disconnected sites. The J-16D is China's attempt to answer this problem. Whether it actually answers it will only be known the first time it operates in a real contested environment against a real strike package. Iran built billions of dollars of air defenses designed to shoot down U.S. aircraft. The U.S. built an aircraft that turns those defenses off before the strike package arrives. That is not a tactical advantage. That is a different category of warfare entirely.